All right, let's take a look at practice day 2. Card 1, Martinez family has a maximum of $25 to spend on activities. Costs $10 an hour to use the trampoline, $5 to use the pool. They can stay 4 hours or less. T is the variable we're going to use for the hours spent on the trampoline. P is hours spent in the pool. Write a system of inequalities. So we have an information about the cost, and we have information about the time. So we're going to have one inequality about the cost. We know that $10 per hour for the trampoline times the number of hours they spend on the trampoline is going to be a certain amount of money, plus $5 per hour times the number of hours that they spend in the pool has got to come in to be less than or equal to $25. They don't have to spend all of their money, but they only have $25 budgeted to spend on this. So that's our money equation, or inequality. And our time one is they can stay for 4 hours or less. So T is hours spent on the trampoline. So the hours they spend on the trampoline plus the hours they spend in the pool has to be less than or equal to 4 hours. So, and the final part of the question, I guess this is B down here, where our system is those two. Can the Martinez family spend 3 hours on the trampoline and 1 in the pool? Well, 3 hours on the trampoline would be $30 plus 1 in the pool. 5 times 1 is what I meant to write there. Do that, that's going to be $35, and they only have $25 to spend, so the answer to B is no, they cannot. Okay, card 2. Jaleel is selling tickets to the school concert. After the concert, he notices a dollar bill on the floor. Adult tickets are $8, student tickets are $5. Cashbox has $310 in it, 47 tickets were sold. He wrote this system of equations, so we're going to solve that system. We could do that in a couple of different ways. So 8x plus 5y equals 310 is one of them. If I multiplied this second equation by -5 everywhere, I'm going to do this by elimination. So I'm going to write that as a -5x minus -5y is equal to -235 is what I believe 5 times 47 is. And if I add those two equations together, I get 8x minus 5x is 3x. 5y minus 5y is 0y, so the y's are all gone. 310 minus 235 is 75. Divide by 3, and it gives me that x is 25, and if x plus y is 47, then that must mean y is another 22. 22 plus 25 is 47. Okay. So, does a dollar bill belong in the cash box? Explain how we know. Well, if they sold 25, this came out perfectly like this with 22 student tickets and 25 adult tickets. And so 8 times those 25 plus 5 times the 22, 8 25s is 200, 5 22s is 110, which works out to exactly $310 as it should. So the answer to B is no. That dollar does not belong in the till. All the money is already accounted for. Card 3. Solve this system. Okay. Let's see. If I look at this, I could make the y's go away if this was a -2 in front of this y. I'll make sure I get this in a place where we can see it. So I can make a -2 show up there by multiplying all these things by 2. That would give me 3 times 2 is 6x. minus 2 times y. 6 times 2 is 12. I'll rewrite the 4x plus 2y equals 8 down here. If I add those together, 6x's and 4x's is 10x's. Negative 2y plus 2y is 0. 12 plus 8 is 20. Divide both sides by 10, and it says the x is 2. And then if I use one of my other equations, 3 times 2 minus y is equal to 6. 6 minus y is equal to 6. Negative y is equal to 0, so y must be 0. And the answer is 2, 0. Make sure that's nice and focused. Card 4. Solve this system of equations. All right. This one is set up to do a substitution. It says y is equal to that. So I'm going to rewrite the first equation, but where I see the y, I'm going to put a negative x minus 1 instead. So this is 2x plus. The other name for y is equal to 3. That's a 2x minus 1 equals 3. 2x's take away 1x, leaves me 1x. Minus 1 is 3. Add 1 to both sides, and the x is 4. And I know that y is the opposite of whatever x is, so negative 4. Take away 1 is negative 5. So x is 4, y is negative 5, is the solution to that system of equations. Card 5. Okay, a school sells 2 kinds of tickets to the spring concert, $12 lawn tickets, $25 seat tickets. The venue can hold no more than 500 people, that's max capacity, and the school wants to make at least $9,000. So X is lawn tickets, Y is seat tickets. Write a system of inequalities. Okay, so there'll be a money and a capacity equation. The venue can hold no more than 500 people. So the lawn tickets plus the seat tickets have to be less than or equal to 500 tickets. Then the money equation, $12 times the number of per lawn ticket times the number of lawn tickets is the money brought in on lawn tickets. $25 per seat ticket times the number of seat tickets will be the money that we bring in from the seat tickets, and we want that to all work out to be more than $9,000. Tells us at the point 150, 300 is a solution to this system. Explain what the solution means. So my answer here needs to have reference to the story in it. Okay, it says that if they sell, X was lawn tickets, so 150 lawn tickets, and 300 seat tickets, they will be under capacity of 500, because that's 450, and make more than $9,000. Okay. Card 6. Bakery sells apple pies for $15, pumpkin pies for $10. Each day the bakery can make at most 50 pies. Okay, so the number of apple pies plus the number of pumpkin pies has to be less than or equal to 50 pies. They want to earn more than $600, so our money equation is $15 per apple pie times the number of apple pies, $10 per pumpkin pie times the number of pumpkin pies. They want to end up with more than $600 from that. So there's my system of inequalities. Will they meet their $600 goal if they sell 25 apple pies and 25 pumpkin pies? So it's asking me, is 25, 25 a solution? certainly 25 plus 25 is less than or equal to 50. 50 is less than or equal to 50, so that's good. 15 times 25 plus 10 times 25. Let's see, 15 times 25, I think it's like 375. 250 plus 7, 325. Get my calculator just to make sure. I know this part's going to be 250 for that. 15, yeah, 325 plus 250 is 575. If I'm asking if that is greater than or equal to 600, it is not, so this is not a solution. Okay, flip her over, card 7. Graph this system of inequalities. So if I want to graph x plus y is greater than or equal to 1, I could make a table of values. Right, I'm basically asking myself, if I want to know where the boundary line is, can I come up with two numbers that add up to 1? Well, if x was 1 and y was 0, that would work. If I'm going to go with x of 6 and y of -5 would also work. 6 minus 5 is 1. So x of 6, y of -5. I like to get it a little farther away from that other point. This is a greater than or equal to, so that should be a solid line going through there. And I should test my point 0, 0. If I put 0, 0 in here, it says 0 is greater than or equal to 1, which it is not. So I'm going to be shaded. I'm going to shade that lightly right now up above. Y less than 5x minus 1. I'm going to use the xy table this time. If I pick x to be 0, then I get the y is -1. If I picked x to be 1, 5 times 1 is 5 minus 1, I get a 4 out. So 0, -1 and 1, 4. That is just a less than, so this should be a dotted line that I'm going with here. Okay. It looks like 0, 0 is not on that line, so if I try that in here, it says, is 0 smaller than -1? Also false. 0 is bigger than -1, so I'm not going to shade this side. I'm going to shade this side over here. And the part that got shaded twice, I'll make that a little bit darker, is right there. So this is where all the good answers live. What is one solution to that? I can pick anything from here. So there's 5, 1, for example, is in that dark shaded area. Card 8. I graph this system of inequalities. Y is less than 3. Well, here's where the y's are equal to 3. This is just less than. So dotted line here where the y is 3. And it says I'm only interested in the y's that are smaller than 3. So that's down below there. X plus 2y less than or equal to 4. I could do this one with intercepts. If I make the x 0, then 2y will be 4 when y is 2. If I make the y 0, cover that up, the x is 4. So I have points at 0, 2 and at 4, 0. That was a less than or equal to, so that's going to get a solid line through there. And I can test the 0, 0. If I test the 0, 0 in there, I get 0 less than or equal to 4, which it is, so that should get shaded below. And I can see the part that's going to get shaded twice is all this stuff down here. So that is where all of my good answers live. What is one solution to that system? 0, 0 is a solution to that system. Okay, that's a point that got shaded twice. There's a bunch of other points, obviously, that got shaded twice there. Okay, card 9. Here is one equation in a system. Write an additional equation so that the system has no solutions. So no solutions was parallel lines. Lines were parallel. If I think back to the lizard lines, this is when we did this. This line would be an equation for a lizard that is crawling 1/3 of a centimeter per second and started at 4 centimeters below the flower. So if I want to be parallel to that, I need another equation where the lizard is crawling at the same pace, but started somewhere else. So I'll put a +2 there. Infinitely many solutions. I'll try to make it interesting. If I multiplied everything here by 3, I could say this looks like 3y is x minus 12. That's exactly the same equation. I've just disguised it a little bit. And for one solution, I just need to pick a different slope. And anything that doesn't have a 1/3 in front of the x should be good to go. So I'll go with a 2x minus 1, but there are, as long as you don't put a 1/3 in front of that x, this answer is going to be right. Card 10. Okay, same kind of situation here. Now this one, it might be more helpful if I could see this thing in that other form that looked like the lizard line. So if I added 2x to both sides, it would say 4y is equal to 2x plus 8. And if I divide everything by 4, 2/4 is a half x plus 2. Okay. So for infinitely many solutions, that's the same. That one's an easy one. I'll go with half x plus 2. There, that's the same line. For no solutions, again, I've got to crawl at the same pace, but start in a different place. So I'll go with y equals just a half x plus 0. It's an easy thing for me to do. And one solution, I'll go with y equals x plus 2. Okay, all I have to do is make sure that that's not a 1/2 in front of that x to make sure that I've got one solution. All right, card 11. Aaliyah graphed this system of inequalities, but she lost the paper with the inequalities on it. What inequalities did she graph? Okay. It looks like this horizontal line here. I know that every point on that line is something comma 2. So y is 2. It's a dotted line. And if I tried like a point up here, 0, 5, should be true. If I put a 5 in for y, should be true. It's bigger than, 5 is bigger than 2, so y greater than 2 is that one. If I think in terms of lizard lines on this one, this looks like the lizard started 3 centimeters above the flower, and then it crawled down 1 centimeter every second. So down 1 centimeter every second, started 3 centimeters above the flower. And if I pick a point that works here, I know that the point, for example, 2, 4 should work. So if I put a 4 in for the y and a 2 in for the x, I get negative 2 plus 3. Comparing 4 to 1, 4 is bigger than 1. Again, it was a dotted line. So it looks like this is what that system should have looked like. And finally, graph this system of inequalities. Okay, I'm going to go intercepts on this one again. If I put a 0 in for 2, 5 times -2. So let me get I put a 0 in for x, y would have to be -2. If I put a 0 in for the y, my x would have to be -5. So 0, -2, -5, 0. That is a dotted line through those points. Let's pick those points up there and sorry about that. Dotted line through there. If I test a point, if I put zeros in for x and y, so I'll test 0, 0. And I get 0 greater than -10, which is true. So the 0, 0 should get covered up with the shading. So the shading goes up there and covers up my test point. Okay, y less than -x minus 1. If I think in terms of lizard lines, that lizard started 1 centimeter below the flower and went down 1 centimeter every second, which I could trace that out that way. So nice dotted line there. I can test 0, 0 on that one as well. If I test the 0, 0 there, I get, 0 is less than 0 minus 1. Is 0 less than -1? No. Okay, 0 is not smaller than -1, so I can't shade above that line. I have to shade below it. And so that looks like shading below it and above the other one is going to give me a little wedge right here where the good answers are. And that's what that should look like. All right, that is it.